All right, let's dive in and actually look at the code and run it to actually find the minimum temperature observed for each weather station in the year 1800. Okay, let's see this filter in action. So go to the resources for this lecture. Again, it's that big friendly blue button in the upper right-hand corner and download two things. One is the min temperatures Python script, and the other is the 1800.csv data file, which contains our weather information. So go ahead and download those now, and when you're done, place them into your C Spark course folder, or wherever you're storing all of the stuff for this course. Go ahead and hit pause and take care of that now. When you're ready, let's go ahead and double click on mintemperatures.py and open that up in your editor. Alright, so I think it makes a little bit more sense once you see this all together. Feel free to take some time to just kind of like wrap your head around it and figure out what's going on here, but I'll walk you through it here too. So we start off with the usual boilerplate stuff, importing what we need from PySpark and setting up a Spark context that we're going to call min temperatures. And if we skip down here, we can see that we're loading up our source data file from 1800.csv into a lines RDD. We then parse that out using our parse line mapper function that we define up here. And what that's doing is splitting out each line by commas, extracting the station ID from the first field, the entry type, which is going to be tmin, tmax, or precip from field 2, and then we will extract the actual temperature value from the third field. And again, we will tell Python that this is actually a floating point numerical value that we can do arithmetic on, convert it from tenths of a degree Celsius to degrees Celsius, and finally convert that to degrees Fahrenheit. And our return value will be this composite value, this list of station ID, entry type, and temperature. So at this point we have every line of our input data converted into this structured data where the first element is the station ID, second value is the entry type, which is tmin, tmax, or precip, and the third value is the temperature associated with that entry in degrees Fahrenheit. Next, we filter out everything with the tmin values here with our filter function. So we check that entry type field in field number 1. If it's tmin, then it survives. If it doesn't, then it does not get passed on. And the resulting min temps RDD contains nothing but tmin entries. So at this point we have an RDD that has the station ID, tmin, and the temperature. Next we can transform that again to eliminate those redundant tmin entries, because everything's a tmin. It's no longer an interesting piece of information. So what we end up with now is a key value RDD, because we'd have these tuples that we're left with that are just station identifier and temperature in Fahrenheit. So station temps is now a key value RDD, where the key is station ID and the values are the minimum temperatures observed for every day of the year for each station. So we're very close to what we want. All we need to do now is call reduce by key to combine together all of the minimum temperatures observed every day for each weather station ID and find the minimum value as we go. So what we're left with is a min temps RDD that has only one entry per weather station ID that contains the minimum temperature observed for the entire year. Finally, we just need to collect the results and print them out and make them look pretty and format them to just be 2 decimal points to the right of the decimal place. So let's go ahead and run this and see what it does. Go to Tools, Canopy Command Prompt, and we will run spark-submit. Too much coffee this morning. mintemperatures.py. Off it goes. The usual warnings that we can ignore, and it should chug through this pretty quickly. There we have it. So the minimum temperature observed in the year 1800 for this weather station ID, which I think is Paris, was 5.36 degrees Fahrenheit. And for this other place, which I think is the Prague, is 7.7 degrees Fahrenheit. There you have it. The minimum temperature script illustrating the use of filters and also using key value RDDs yet again. So there you have it, the minimum temperature observed in the year 1800 for 2 weather stations. We used the concept of filters, we used key value RDDs, and we used the reduce by key function to actually boil down the information we wanted for the whole year for each weather station ID. Pretty cool stuff. Now I want you to get your hands dirty. I want you to roll up your sleeves and actually dive into that code and start messing with it. Get some confidence, especially if you're new to Python, that you can make changes to this code and actually make stuff happen yourself. So here's what I want you to do. Pretty simple task. Take that code that we just wrote for the minimum temperature for the year and change it to actually find the maximum temperature observed for each weather station throughout the year 1800. So again, instead of displaying the minimum temperature found for the whole year, I want you to tell me the maximum temperature found for the whole year for each weather station ID. Shouldn't be too hard, just a couple of things you have to change in there really. So give that a try and come back in the next lecture and we can compare what you came up with to what I came up with.